Today, our objective is to use the distributive property, or multiplication, to simplify polynomial expressions. So a quick review of exponent rules. When we multiply x by x, that gives us x squared. Anything multiplied by itself is that expression squared. When we multiply 3x times x, that's the same as 3 times x times x. Well, we know that x times x is x squared, so that's just 3x squared. Remember that coefficient is multiplying the x squared. And lastly, we have 5x squared, which is the same as 5 times x squared, and 2x squared, which is 2 times x cubed, and we are multiplying those together. So multiplication, you can change the order and do in whatever order you want. So I'm going to multiply 5 by 2 first to get 10, and then x squared by x cubed. Let's see, x squared is x times x cubed is x times x, so I have x multiplied by itself 5 times. We call that x to the 5th power. Here are some examples of using the distributive property to simplify polynomial expressions. This -3 is touching this parentheses, which means that it is multiplying each of the terms in the parentheses. Sometimes we remember the distributive property by drawing these arrows to remind us that the -3 multiplies all 3 of those terms. So when I multiply by -3, I have -3 times x squared plus -3 times 5x plus -3 times -2. So I like to do a little plus sign right there. Remember that a negative times a negative is a positive, so I'm going to end up adding 6. Remember, -3 times x squared is just -3x squared. -3 times 5x gives us -15x, and then a negative times a negative gives us plus 6. So our final simplified polynomial is -3x squared minus 15x plus 6. And that would be a quadratic or second degree 3-term polynomial. In our next example, we have 3x being distributed. Again, there's no operation between the x and the parentheses, so I know that we are multiplying. So I am going to draw my arrows to remind me to multiply both terms by 3x. So 3x times 2x is going to give me 3 times 2 is 6, times x is x squared. And then I'm multiplying 3x by a minus or -1. So I have minus 3x. In our last example, we are multiplying -3x squared by each term inside the parentheses. So I'm multiplying -3 times 5 is -15x squared from here. Then I'm multiplying -3x squared times -3. That gives me plus x squared times x is x cubed, so plus 9x cubed. And then finally, -3x squared times x squared. Well, x squared times x squared is x to the 4th, and I still have my -3, and that's a positive, so I have minus 3x to the 4th. Now that we've reviewed the distributive property, we can use this property to combine the distributive property over multiple polynomial expressions. So our steps for simplifying polynomials are: first we distribute if we can, then we combine our like terms, and finally we put our polynomial in standard form. So let's take a look at this first example. I have the 5 in front of the parentheses, means I'm multiplying this 5 by the x and the positive 1. Here I'm subtracting 2x times each of the terms inside here, and that gets a little tricky. We can think of it as adding a negative 2x times those things. That minus sign kind of belongs to the 2x as a negative sign. Okay, so let's start with the 5. I have 5 times x is 5x, and 5 times 1 is 5. Now I am distributing, think about distributing this as a negative 2x, and we are multiplying it by x squared. So I have minus 2x times x squared is 2x cubed. And then I have minus 2x times x is going to be minus 2x squared. Now I'm looking for my like terms. I don't see any. I see a cubic term here, or a third degree term. I see a second degree or quadratic term here, a linear or first degree term, and a constant of 5. So I'm going to write those in order. Negative 2x cubed minus 2x squared. In our next example, we are going to be distributing the 4 to the x squared and the x. And then we have this minus 3. We can think of this as distributing a negative 3. We can kind of think of this as adding negative 3 times that polynomial. So I'm going to distribute that negative 3 through there. So I have 4x squared plus 4x. And then I have minus 3x squared and minus 3. Here, my like terms are just the 4x squared and the minus 3x squared, which combines to be 1x squared, or just x squared, plus 4x minus 3. And now we have a simplified polynomial in standard form, quadratic or second degree term, linear or first degree term, and our constant of negative 3. In our last example, we're going to distribute the 5x through this polynomial, but then I'm going to show you another method, just previewing for you the box method for multiplying multi-term polynomials. So here I'm going to multiply the 5x times x squared. That will give me 5x cubed. Then I'm going to multiply the 5x times 3x to give me 15x squared. And then finally, 5x times negative 4, you can think of that as plus negative 4 or minus 4, is going to give me minus 20x. So this is one method of multiplying this single-term polynomial times this 3-term polynomial or trinomial. I'm going to introduce you to another method that will prepare you for multiplying polynomials that each have more than one term. And you can either start that now if you're ready by watching video 4, or you can wait until tomorrow if you feel like you need practice with the distributive property. So here's how the box method or area model works. I'm going to take this 5x and put it on one side of a rectangle. And I'm going to take this x squared plus 3x minus 4 and make that the length of the rectangle. So I now have a rectangle that has 5x as the length and x squared plus 3x minus 4 as the width. And I'm just going to complete this rectangle so that it looks like a rectangle. And I'm going to break it according to that trinomial so that I have 3 rectangles. So my first rectangle is going to have a length of x squared, a width of x squared and a length of 5x. Well, if you remember, when we find the area of a rectangle, we multiply length times width. So I'm multiplying 5x times x squared to get 5x cubed. Notice that that matches with our 5x cubed up here. In the next rectangle, I am multiplying 3x times this length. But remember, it's a rectangle, so these all have a length of 5x. So I'm multiplying 3x times 5x. That gives me 15x squared, which corresponds with my 15x squared from this method. And finally, I have my last rectangle, which is 5x times -4. That gives me -20x, which corresponds with my final term. So one method is distribution, but as these polynomials get more complicated, it's nice to have a visual model to help us get from each of these terms that we get by multiplying back to our simplified polynomial. So if you're ready to try that more difficult multi-term polynomial multiplying, go ahead and start the video for day 4. If you feel like you need more practice using the distributive property, go ahead and get started on the practice for that first.